What's up, y'all? I'm recording a short video here to help with the Vernier graphical analysis version. So some of you are going to be using the Go motion sensors on your Chromebook, and it's a little different than the LabQuest video that I just recorded. So here's the quick version. Obviously, you plug it into your Chromebook. You can see just random data here, but I'm going to collect some new data to represent your cart moving away from the motion sensors. So give me just one moment here. Okay, we got good data there. Now you'll notice that and your thing will keep clicking until you hit the little trigger button, by the way. So if you get tired of your clicks, you can press trigger. You'll notice that it's kind of zoomed out. So the first thing I would do is click the little minus, which is zooming in on both graphs. And you can see clearly here a curve, which shows that we're accelerating, which is good. We can see here the kind of linear portion, which is where I was actually accelerating before I started moving at a constant speed around 0.9 seconds. And the nice thing about the Vernier graphical analysis here is you can click on the graph button in the top right corner, change it to 3 graphs, and it'll actually generate your acceleration graph for you. And of course, you can zoom in just like on the other ones. And then on that, I can see that, well, when I was having this slope here, it corresponded to approximately looks like about a 2.5, maybe a little higher acceleration. Obviously, if you want a more accurate data value, we can actually just turn on here for velocity, the tangent line, kind of like we could see on the LabQuest. And then I can click at different spaces to find the tangent or the slope at that point. So I can see a slope of about 3 meters per second squared, about 3 meters per second squared. Another thing you can do is highlight the data like you did on the LabQuest, and you can find your average by doing a curve fit, linear, apply, and you'll see that the overall kind of range there. Let me close out this acceleration graph. I think if I click this, go away. If I turn off this graph, there we go. Now I can actually see my slope there, which is 3.9. So that's going to be a little bit more accurate way to do it rather than just using the tangent feature. But theoretically, either way, you can find the acceleration for a given mass, aka a given force, and then a given trial as you're doing your experiment. So hopefully that's helpful. And if you have questions as you're working, of course, let me know.